Good morning, everyone. Geometry. These are the notes for 6.1, which are based on ratios, proportions, and the geometric mean. Now, most of this is going to be reviewed for you, except for maybe the geometric mean. So let's just start with what a ratio is. If I told you the ratio of, let's say, A to B, do you know there are ways of writing that? Well, we could write it as A dot dot B. You've seen that before. But really, a ratio is truly just a fraction, and I think you've seen that before. I want to remind you that ratios are always expressed in the simplest form. So I'm going to write that. They are expressed in simplest form. What I mean by simplest form is I'm going to put it in real big, reduce, reduce, reduce. Okay? So for example, if I had, let's say, an equilateral triangle, that's 2 centimeters by 2 centimeters, 2 centimeters, and then I had another triangle that's 1 centimeter by 1 centimeter by 1 centimeter, okay, these side lengths, and I was asked what is the ratio of the big triangle to the small triangle, I could say that this was a 2-to-1 ratio or even a 2-to-1. Now the object or the side that's listed first always goes on top of the fraction. So if they say big to small, you'd have big to small. Okay? All right, quick reminders. Proportions. A lot of students mix up ratios versus proportions. Proportions are just an equation saying that two ratios are equal. So a proportions are an equation, I'm just going to write that, an equation stating two ratios are equivalent. Let's use a math word. Equivalent or equal. Okay? So a lot of times we see that, I'm going to move this up, we see that as something looking like A over B, this fraction equals C over D, this fraction. Now in geometry, well in math, these positions have names. This position and this position right here are called the means. That's a mean and that's a mean. And then this position and this position right here are called the extremes. And that may be new. Okay, and we're going to need that for when we deal with something called the geometric mean. So I don't know if you remember how to solve proportions. There's something called the cross product, or what's also called the butterfly effect, that we can multiply across and set these two pieces equal to each other. So we could say that B times C equals A times D. Do you remember that? So here's an example of how we actually solve proportions. Okay, so I'll write solve, and I have something like 5 over 10 equals x over 16. Now, you can probably do this in your head. You know that 5 over 10 is 1/2, and 8 over 16 is indeed 1/2 as well. But let's just use the cross product so that you can see that this is indeed how you can solve something like this. 5 times 16 is 80, and x times 10 is 10x. We solve by dividing both sides by 10, and we get that x equals 8. Ta-da! Right? We can kind of see that. What if we were given something scarier, where you've got more than one variable, or something a little bit meaner? So let's do 1 over y plus 1 equals 2 over 3y. Now this one's not as obvious just looking at it, but any proportion where you have two things equal to each other, you can always use the cross product, multiply across. So we have 2 times y plus 1. Don't forget that this is 2 times the whole thing, so that's why I use my parentheses, equals 3y times 1, which is just 3y. I'll put a 1 here so you can see that that's the math I'm doing. I'm going to distribute, so I have 2y plus 2 equals 3y. Solve for y, so I'm going to subtract 2y. I have 2 equals y, so y equals 2. Nice and easy, right? All right, so let me turn this over. Let's talk about something that's actually new. You've done ratios and proportions in algebra. This is called the geometric mean, and this is new to you. And we actually use geometric means to solve side lengths in triangles, which is pretty cool, which we'll do shortly. All right, the geometric mean looks like this. If I had a over x equals x over b, all right, And I'm going to say that A is positive. That's what A is greater than 0 means. A is positive. and b is positive. So let's say that both of these are positive numbers. Then using the cross product, right, or what I used to call the butterfly effect, x squared has to equal a times b, right? And if I wanted just to know that number, to get x by itself, can't I square root both sides? So I get x equals the square root of a times b. This is how you find the geometric mean. Okay, so here's an example. So we'll do example number 3. Find the geometric mean. Find the geometric mean of 36 and 54. What they're giving you A and they're giving you B. So all they're asking you to do is say, multiply those two together and take the square root. Right? That's what they're asking. They're giving you 36 and 54. So you multiply those together. By the way, you can either multiply those together, or legally with square roots, and hopefully you learned this last year, you can actually split these up and treat them separately. Square root of 36 is 6. This is all multiplication. Times 54, you can actually break this up to be the square root of 9 times the square root of 6. Square root of 9 is 3. And then we have 6 times 3, which is 18. And the square root of 6 we can't mess with. That's as simple as we can go. That is the geometric mean. Okay? All right. Good luck today on your homework.